Here I'm going to demo Simularity's Map Image Explorer, which can be used to examine anomalies in satellite images. The first step in the day in the life of an analyst is to sign into our application, which I'm doing right here. And I have predefined in earlier uses of this application my areas of interest. Now, defining a new area of interest is as simple as grabbing this pencil over here and drawing a polygon. Voila, I have a new area of interest. Here, I can give it a name. And I can set an anomaly threshold. I'm going to set it really low here so that I'll see any changes, even the smallest ones, that happen in my area of interest. And now I've got a new area of interest. It'll show up over here in the anomaly list, Liz's new area. There aren't any images in this area right now because the system has not automatically loaded any, but assuming the customer had a subscription to this area, the images would show up automatically under that area immediately upon creation of that area of interest. Now it's easy to go ahead and delete that area of interest as well. Let's take a look at the areas of interest that we've analyzed for this test, specifically the areas in the Middle East. You can zoom to each area by clicking on this target button in the area title, and you'll see the area of interest in a rectangle. This one has a red rectangle because an anomaly has been detected. And it'll also show you the image on the map here. If we zoom out a little bit, we can see the further details of the map here. And in order to compare this image with the previous image and see what the anomalies are, we click on the thumbnail and can go to this detail examination of the image. Over here, it shows the anomaly score and the anomaly image. If I click on this, the anomaly image will be displayed right on top of the visual image that came off of the satellite. The white indications here are the indications of the anomaly that was detected. And so if you want to compare the anomaly that was detected to the visual image, you can click back and forth. And I find this a really good way to see where on the image the anomalies are being detected. We also wanted to make sure that we weren't detecting anomalies where there weren't any. And so we can go and look at some of these other areas in other images inside this same area. And here we've got a view of an image inside this same area. This one is from August 5th of 2016. And you can see the anomaly score is 0. And here there are no bright spots on the anomaly image. So and in the visual image, no apparent anomalies. So that's good validation that we are not finding anomalies where there aren't any, which is good. There are a variety of different terrains in these different area of interests that were provided. Some of them are very clear, like the image in Kuwait of the desert. Others are very cloudy. Here is an image in area 9 of Egypt. And this particular area gets an enormous amount of clouds. And so here we're looking at the visual image, and you can see both the clouds and the shadows of the clouds that are on the ground. Now, Planet has an algorithm that can take out the cloud shadows in the image. And that's what you're seeing here, or take out the clouds. And so that's what you're seeing here. These red areas are transparent where Planet has removed the clouds from the image. which is an outstanding feature. However, dealing with the cloud shadows, not as easy to do. Those still remain in the image. So when we look in the anomaly image, the clouds are removed that were in this image, but we see cloud shadows showing up as anomalies. And that makes areas like this that are very cloudy on a frequent basis difficult to do anomaly detection in. However, there are areas in here that are towns and villages that may have anomalies. So you can see that bright spot there. Those may or may not be clouds. Let's go take a look at this area in the image down here. We can keep our eye focused on this area that we want to look at. That's the little zoom window that we see over here on the left. And flip to this and zoom in on this. And it's hard to tell. Those look like clouds, really. So I wouldn't end up calling those an anomaly, even though they did end up showing up on this anomaly image as brighter. Those look like clouds that may not have been removed from the image. And so using the map, we can see that anomalies are highlighted in these red squares along the map, and we can pan and zoom around our area of interest if we like. This is the Middle East, and you can see the different areas where anomalies have been detected. And you can select that area and zoom into the details on it. And here we've got another fire in the desert that we have detected as an anomaly. And again, the anomaly image here shows very clearly that it's the fire that was detected as the anomaly. And the composite image, which is the image of what these pixels look like just prior to the image that is being analyzed, clearly shows no fire there. So going back to the large map, here we're zoomed in on the area we just looked at. But going back to the large map where you can see all the different areas of anomalies, if you were an analyst responsible for analyzing the Middle East and satellite images, this is what your daily screen might look like. Well, hopefully it's not this many anomalies, but here in this case, we've got all the anomalies mapped out that were detected in the historic data that we were provided. And so you can see you don't have to go and set up new areas of interest every day when you start analyzing. You just log on to your account, and any anomalies in your predefined areas of interest are flagged in red and are very easy for you to look at. You can also look at them in the list over here of anomalies. And one of the areas that's really particularly interesting is this area in Syria. By clicking here, we'll zoom into that area. This happens to be Aleppo, and there have been a fair amount of fighting going on in Aleppo in the last year or two, and evidence of that is shown in these images that we're looking at here. So here is a fire that is most likely the result of a bombing raid, and it shows up clearly in the anomaly image here as the anomaly. You also are able to see small anomaly here. What I did by unclicking this is make all the areas that are transparent on the anomaly image show red. It shows all the way through to the background. Let's take a look at this anomaly here that seems fairly bright and is not this big fire. By hovering here, I'm going to bring up the zoom window. Depending on how large the image is, it can take a little while to load up the full detailed window to allow for the zoom. And we can also look at what's going on in the visual image by going back and forth. If you look if you focus your eyes in on this area right here, and now you can see we've got the zoom working, we see sort of an amorphous shape. Let's go look at the visual image in that same area and see what that shape looks like. That looks like it may be a cloud. I'm talking about that dark area in the middle of the screen there. It might be a cloud shadow, or it is maybe almost more likely to be smoke caused by another bombing or a fire. So in looking at the images for Aleppo in area 6 here, it was very interesting to see that on many different days. So this one was on August 15th, but again on August 18th, we've got another example of smoke and fire over here. You can see that highlighted really clearly in this anomaly image over here. And while it looks like there's a lot of bright spots here, if we uncheck this, we can see those are all red. Those are all transparent. But there are some smaller anomalies in here that we could choose to zoom in and investigate. Some specific buildings there, and again, more specific buildings here. And the way we can choose to investigate this could be to open up a much bigger view of this area and be able to zoom in much deeper and look at all of these anomalies and bright spots. By opening a new window, clicking on this blue dot here will do the same. We can do it for the visual image and again, zoom in on all of these areas. And without an anomaly detection tool, finding changes in this image is going to be incredibly difficult. And what you're comparing it to is this image or this composite image, which represents all of the pixels put together that were the most recent view of this area prior to this new image being taken. And you can see that this composite image has cloud shadows in it as well, which makes it, again, even more difficult to do a visual comparison about what's changed and what hasn't. And so here we are zooming in on the different areas inside this prior image, noting that, you know, some of the colors are different because this composite image is composed of all of the most recent pixels that make up that specific area in the image that we were just examining. So once I am able to zoom out into this whole file here, what we can do is save this image out. And let's call this test one. And save it. And we can then look at that image in other tools. So you'll see that in your list over here, the images are ordered by highest anomaly score. They're also ordered by date. If the anomaly score is the same, for example, here you've got zeros, then the newest image is shown first in the list here. And once you're done examining these images, one of the enhancements we'd like to add is the ability to mark an image as examined so it doesn't show up in your list anymore. Another feature we'd like to add is the ability to set a time frame, a time range for images that you're interested in looking at. For this exercise here, we ended up looking at all historical images in these specific areas. And one of my favorite areas was in Abu Dhabi. And what we were able to find here in this very interesting image with a lot of different changes in the water and the sand levels is an anomaly over here in this part of the image where a new building was built. And as we wait for that full anomaly image to be loaded, you can see that while these shapes show up as anomalies, it's clear by how they look that they are not man-made anomalies. However, over here, there's a very bright little area that is a geometric shape that is a man-made anomaly, and that's the anomaly that we're going to take a look at. And so if we focus our eyes in on that and switch between looking at the composite image and the anomaly image, we can see there's definitely a building here for us to take a look at. And if we look at and check between the anomaly image here and the composite image by clicking on this, here it comes. We can see that this bright spot here is actually not represented as anything in this composite image. So let's go back and take a look at that anomaly one of these days. These images are really huge, so sometimes they can take a while to load. Here we go. It looks like a Z-shaped building. You can see that right there, that very bright spot. And if we go and look at that image over here on the visual image, we'll be able to see that same Z-shaped building that is not there in the composite image. So there it is. There's our beautiful Z-shaped building. And that's a new building that we were able to detect as an anomaly there. So this is just a quick tour of how our Anomaly Explorer app works, how you can find the images you're looking for, define the areas that you want to look at, and pick which images you examine in greater detail from this anomaly list over here. As part of this test, we analyzed thousands of images, and not all of them are loaded here because that would make this somewhat unwieldy, especially if you didn't have a way to mark these as images you didn't want to look at anymore. But here we do have a handful of images, some with anomaly scores and some without. And will provide you the ability to access this application and examine these for yourselves. Thanks.